Hi everybody, and thanks for joining me today on Danfoss's EnVisioneering Connect virtual conference. My name is Victor Marinich. I'm the Global Marketing Director here at Danfoss, and today I'd like to talk to you about the path forward towards more efficient dedicated outdoor air or DOAS units and rooftop units. So maybe we want to ask first, take a step back and look at why are a lot of these changes coming into the market. There's a few big global megatrends that we're following here at Danfoss. I think the ones that impact us the most on the air conditioning side are climate change and urbanization, right? And then of course electrification and digitalization are also going to work with us there. If we look on climate change, right here, this is really what's driving most of our efforts here at Danfoss, and it's about making more efficient units, because of course the greenest energy is the energy that we don't use, and also about using chemicals, refrigerants that are going to be more safe in our environment. So climate change is something really important we work towards. And urbanization is something we know the UN is saying we're going to see millions of people moving from the countrysides and into the cities. And as you're moving into the cities, right, that's going to mean more housing needs, and in those housing we're going to need air conditioning, we're going to need heating. So we're going to see more air conditioning coming, and we need to make sure that we're developing these systems in an environmentally friendly way. And then, of course, we don't want to be burning fossil fuels, right? So we're going to want to have more and more electricity as our main power supply. So if we look how this impacts us in North America, the biggest thing we're going to see is impacts coming from the AIM Act. The AIM Act is legislation that was signed in late 2020, and that basically gives the EPA the mandate to control our phase down in our of CO2 emissions. So you can see on the chart that we're scheduled for a big drop in CO2 emissions in 2024. Here it's dropping down to 60%, so a 40% reduction in CO2 equivalent emissions. So how does that impact us on the air conditioning side? All of the refrigerants we use today have a GWP, which are measured in CO2 equivalent. So for example, the most common refrigerant today in air conditioning is R410A, and there it's got a GWP of 2088. So come 2024, we in the market either need to use 40% less R410A, and of course that means 40% less units, 40% less service and everything else, so that's not really an option. Or we need to use a refrigerant that's at least 40% lower GWP, so yeah, wherever that puts that, somewhere around 1200 GWP. So the market, of course, has been working for many years. Our OEMs, our customers have been working towards it. People like ASHRAE and HRI have been working towards finding replacements. And what we expect to see legislatively coming is they're going to set a mandate of 750 GWP limit on any new refrigerants. This isn't in law yet, but what we would expect to see is a limit of 750 GWP impacting chillers first in 2024. And chillers are easier, right, because they're outside, so there's not so much risk of getting refrigerant leaks in the buildings and so on, which is going to be pretty important, as I'll mention here in a minute. We expect to see rooftops, DOAS units, and other package units also coming in 2025. And then by 2026, we see these requirements coming into VRF units. So that's some big changes coming into our market for the coming years, right? We've been working with R410A now for well over 10, 15 years, and now we're going to have a pretty big change coming up. So as you saw, we need to make some changes in the refrigerants that we're using in systems today. And when we have R410A as the primary refrigerant we see today, we know the two leading solutions going forward are going to be R32 or R454B and maybe R452B. Now the big challenge we have with both of these refrigerants is that they are A2L classified, meaning they're mildly flammable. So that means we're going to have some safety precautions in place that we didn't have today with R410A systems. So now why would you pick R32 versus R454B? A couple different reasons. And there is no right or wrong answer. It really is up to the manufacturer what works best for them. What we see in general, R32 is a higher pressure, higher density refrigerant. So what that means is you can get more capacity in your system, so you can design yourself a smaller system, maybe reduce your pipe size, reduce your heat exchanger size, reduce the size maybe some of the valves, right, your overall base of the unit, and so on. So if you're going to reduce the size of the unit, hopefully you reduce the costs as well. The downside with R32, because it is higher pressure, you're going to have to make sure your components are all rated at that higher pressure. And that's something that the manufacturers can help with. 454B, on the other hand, was really engineered to be a replacement for R410A. It's a blend of R32 and R1234YF, and it's meant to have pressures and performance similar to 410A. So it's very much I don't want to call it a drop-in, because you can't drop it in from one unit to the next, but it's really meant to mimic R410A. So the upside is probably the components you're using today in your 410A system are all going to be the same ones you use in 454B system. So you're going to get similar capacity, similar performance. So that really saves you a lot of effort on design. It saves you a lot of effort in your labs. Again, the downside is maybe you don't take advantage of eliminating, right, going to smaller parts, reducing the size of the overall unit. So it's a trade-off maybe in optimizing the design, size, capacity-wise, versus your time to market. So it really is up to the manufacturers on which refrigerant it is they want to choose. Either way they go, or another option, of course, you always need to make sure you have a compatible product. So everything that you're using in the system needs to be compatible with the new refrigerant, and of course the suppliers, the components can help there. And to check the performance, because we need to make sure obviously that we're hitting still the efficiency standards that are mandated. The temperatures and pressures, those are going to of course make sure that you have the right safety components in place to keep the system running safe, and the overall price, right? The price of the refrigerant, the price of the components going into the refrigerant, and then the size of the unit itself. So you take all these things into account, and you can pick the refrigerant strategy that works for you when it comes to unitary products. So we have the refrigerant issue at least discussed and solved, and there we have until probably 2025 to come up with a solution. But on top of that, what we see in the market today is the volume of units that are out there, right? Because we think it's a small little 5-ton, 10-ton rooftop, doesn't have a whole lot of meaning. But if we look at U.S. government statistics, show about 47% of all the buildings in the country, and that's out of a base of 6 million buildings, are using some kind of a unitary product. So if we add that up, that is a lot of refrigerant that we're putting into the field, right, and a lot of units going up on the roofs. So it really is important that if we're going to battle global warming, battle climate change, that we're going to get a lot of these units on the roofs that have these low GWP refrigerants. So as you can see, there's really a lot of rooftops, DOAS units out there in the market today, and that's why we need to make sure that they're running efficiently and running with green refrigerants. So there's a lot of things that have been put on the manufacturers of rooftop and DOAS units as of late, and that's kind of how we got to where we are. So as I mentioned already, right, this energy efficiency is a big issue that they need to design to. We're talking 15% increase over the existing designs. They have a refrigerant change that they need to manage. They have to design for now an A2L, a mildly flammable refrigerant. So again, not such a simple change for them to make, right? They have indoor air quality. That's really becoming an issue right now, right? 5 years ago, if we just had cold air coming out of the vents, we were way happy, right? We weren't sitting outside in the hot sun. Great. Today, that's not the case, right? I mean, given the pandemic that we've just gone through, people expect not only just cold air, right? We want the right temperature air. We also want good humidity control so we're comfortable. And most importantly, right, we want to know that it's clean air, filtered air, safe air that's coming in, fresh air coming into our buildings. So we've got to take all these things into account with that next generation rooftop and DOAS units. And then, of course, some of the things that installers and end users like, right, is connectivity or Internet of Things on the units. Having one unit run efficiently is of course important, but then when you talk a big strip mall or shopping center where you've got lots of these rooftop and DOAS units, of course you want them all talking to each other. right? Having one unit run all the time while the unit next to it is shut down isn't the most maybe efficient way to use all those units. So you want them talking to each other. You want to make sure that you're really optimizing your whole building and not just optimizing one unit here or there. And of course, with IoT, we have preventative maintenance, right? Maybe we know when a belt is getting ready to fail or when a compressor has stopped working within its operating range, and we can do some maintenance there. That's becoming more and more important as well. And then last, we see really a big continuous push on resources. And I think there's two different ways we can look at resources. One are the human resources, because again, redesigning for a new refrigerant, redesigning for a higher efficiency, that's a lot of lab work. That's a lot of engineering time that's going into getting these units to be efficient and to be safe. And that's a lot of work that all the manufacturers have to do. Secondly, from a resource standpoint, right, it's the raw materials themselves. We've all seen, especially as of late, copper going up, steel going up, aluminum going up. We see all these prices going up, so we want to obviously minimize the materials going into the unit and not just make a unit that has a heat exchanger 50% bigger than it is today, which maybe will help you get the efficiency done, but certainly not a good use of raw materials. And if we look back, of course, on climate change, right, we don't want to be taking all these raw materials out of the ground, throwing them away, right? We want to make sure that we're minimizing the impact we have on the environment with the materials that we're taking out, right? And then finally, our last point that, especially here in North America, is I think going to be something maybe a little new, and that's a move away from burning fossil fuels, natural gas and heating oil, and going to electricity for heating. So in the US, rooftops, typically when they have heating, it's going to be a gas-fired heater, right? So, or maybe hot water running through there. So it's going to be some type of fossil fuel that's going to give us heating on the rooftop units. I think roughly today about 10% of rooftops today are reversible heat pump units. Going forward, right, we want clean energy. We don't want to be burning these fossil fuels. So we want to work with electricity, and that really means heavy investment in reversible systems. So a heat pump, when we talk about a rooftop, is really just a unit running in reverse, where rather than blowing all the hot air out and blowing the cold air into the building, we reverse that cycle and blow the hot air into the building and pull the cold air out. And so that's something we're going to see more and more of going forward. And that's really not just for rooftops, also on the residential side. And that's something we haven't done a lot of in the US. I think heat pumps have maybe got a bad name in the US because we tried them back in the 70s. Some of us were around in the 70s. And what we thought were, it was too cold of air. It didn't work when it was low temperatures. There were a lot of complaints on the heat pump. This technology has really come leaps and bounds since those first heat pumps were introduced. Today they work in low ambience. Today you get warm air. So it really is a good alternative and not a sacrifice to move to a heat pump. So look for those also coming very soon when we talk rooftops and DOAS units. So in general, right, I've been covering both rooftops and DOAS kind of together as if they're the same. They look fairly the same, do mostly the same work, but there is obviously a different in a dedicated outdoor air unit, because it does exactly what the name says it does. It takes 100% outdoor air and brings that into the building. Whereas a rooftop unit works maybe like the air conditioner you have on your home, where yes, some fresh air is coming in, but for the most part, we're recirculating the air. And of course, then it doesn't take that much effort or energy if you've got the mall air leaving at 80 to bring it down to back to 75 degrees again, right? A DOAS unit, you're taking that outdoor air, regardless of the temperature, regardless of the humidity, and having to condition it to be something that's comfortable in that living space. So a dedicated outdoor unit really is a special piece of equipment, and it works in conjunction with a rooftop unit or other types of air conditioners. So what you can see is the dedicated outdoor air unit will help you pull the moisture out, right? What we call the latent load. We'll pull that out, basically the moisture, and then bring dry air into the building and condition the air to the temperature. That allows the rooftop to then focus just on the sensible load or just the temperature change. So the rooftop unit's not worried now anymore about taking in humid air. It's just purely recirculating the air that's in the building. So the dedicated outdoor air unit does a similar job, but it's working hand in hand with that rooftop unit. So some of the benefits you're going to see on the DOAS unit, again, we're going to separate the latent and the sensible loads. So that means the DOAS is going to focus more on moisture, if you will, and the rooftop on the temperatures. And what that's going to do is also let you reduce the size of that rooftop unit. The rooftop no longer has to worry about pulling moisture out of the air, taking in outdoor air. It's just recirculating, so you can get yourself a smaller rooftop unit. So that's going to save you some cost there. You're going to get good ventilation at a broader range of the ambient conditions. It's going to allow you to, because that dedicated outdoor air unit is really optimized to work in those worst case situations, you're going to get a much better range on the air conditioning. The dedicated outdoor air unit also has a lot more filtration, because obviously you're taking fresh air in, so you're going to have an improved indoor air quality. Because one, of course, you're not just circulating air, so any contaminants that are in that, whatever it is, shopping mall or office building, don't just get circulated. You're bringing in fresh outdoor air with the dedicated outdoor air unit, filtering it and bringing it into the building, so your air quality really goes way up as well. So you're going to get dehumidified and filtered air, fresh air coming into that building more than just circulating the air. So the DOAS unit really is a nice complement to the rooftop units that we're looking at. And then finally, when it comes to the design of either one of these pieces of equipment, Danfoss offers a full range of all the components you would need to design the unit. From our line components, where we have expansion valves, both mechanical and electric, solenoid valves, filter dryers, sensors to make sure that your system is running optimally and running safely. We have our MCX controllers that will help control the entire rooftop unit, managing the compressor, the fans, the refrigerant flow, and so on. We have a full line of compressors. As I mentioned, everything from our fixed speed DSH compressors, available for multi-refrigerant versions or our DSF R32 versions, for your entry-level efficiency product, all the way up through tandems, and then variable speed compressors. So there we take a standard compressor, optimize it to run over a range so that you can modulate the capacity coming out of the compressor, right, and optimize your system design. Both evaporators and condensers are indoor and outdoor heat exchangers in microchannel, which will help you minimize the refrigerant, which is really important when it comes to converting to A2Ls. We want to minimize the charge that we have there. And we have a full range of drives to put on any of your fan motors to control the fan speed. So from Danfoss, really when you're looking to do that redesign, whether it's for efficiency or for the refrigerant change, we've got the components that you need to optimize that system. And then finally, I'd like to introduce you to a case study that we've done. It was based out of our Advanced Development Center, or ADC, in Tallahassee, Florida. We have a full lab down there where we can bring in units, rooftops, DOAS, and others, and run a full battery of tests on them. So in this case, we partnered with one of our customers. They were manufacturing a DOAS unit and were having some issues on control in certain conditions, and we're looking to increase the performance of the unit. So we took the unit into our development center, benchmarked it, and then went ahead and replaced the unit with Danfoss variable speed compressors and Danfoss microchannel heat exchangers, both on that outdoor coil, indoor coil, and the reheat coil. And then we reran the unit. When we reran the unit, we found we were able to reduce the refrigerant charge in that unit by 31%. And again, we're talking A2L refrigerants. That's a big increase, or a big reduction, rather. We were also able to improve the ISMRE, which is a rating for moisture removal efficiency, by 30%, and we improved the efficiency, or IEER, by 16%. So we talked previously about this big constraint on resources, and one of the resources under the biggest constraint are lab time and lab people. And at Danfoss, we know that, we understand that. We have these ADCs, Application Development Centers, globally here in North America. Ours is in Tallahassee, Florida. And it's available, we use with our partners to do exactly these kinds of things to improve your systems, to prove out solutions, and to help you get to market faster and with a better product. And so with that, I'd like to thank you for participating in the Rooftop and DOAS session. I invite you to participate in the other EnVisioneering Connect sessions that we've got running today. You can find more information on the information discussed here in the related content. And with that, I'll open it up to questions.